Good day, ladies and gentlemen. My name is Dr. Siziwe Koba, a PhD holder from the University of Fort Hare. Welcome to the NSW 2021 conference. So today, my talk, actually before I give my talk, let me firstly thank SASTA for this opportunity that they have afforded me to be on this conference. It is such an honor. It is such a big privilege for me to be a part of this. Because this is who we are, this is what we do. Imparting knowledge to the youth of the country, exposing the youth to endless possibilities that are available through science and technology. Okay, so my talk will be, firstly, I'm going to tell you about this facility that we have here at the University of Fort Hare, which is called Revel. I'm also going to tell you what the facility aims to do. And then I'm going to show you one component of the facility. Okay, so what is this Revel that everyone keeps talking about? Revel simply stands for Remote and Virtual Educational Lab. It is situated here at the University of Fort Hare, Department of Physics. So this facility would not have been possible if it wasn't for our partnership with our international partners, which is Labsland. And I must also mention that there's only 3 countries in this world where you will find this facility. There's one in Spain, there's one in Colombia, and this one here in South Africa. So this is a first of its kind facility in the country, not just in the country, in the continent. Yes. Okay, so what are the aims of this facility? Why was this facility established? Okay, so the establishment of this facility was prompted by a number of imperatives. One of the objectives of the facility is to create a teaching and learning environment to bridge the gap between well-resourced higher educational institutions and those that are economically challenged institutions. The other objective of the facility is to enable rural-based science schools with inadequate lab equipment to access and operate real science experiments online for teaching, for quality teaching and learning process to occur. No? So this speaks so much to me, this particular one, because I remember we did not have any labs. So we'd have to use our imaginations when we're doing experiment. You'd just be thinking, oh, okay, maybe this is how the experiment goes. Oh, okay, you had to use your imagination. There were no labs. So this bridges the gap between such privileged schools and those that are not so privileged. So this is what this facility is about. So my colleagues have touched on different components of the facility. We had Mr. Boy talking about the physics experiment of the physics experiments component of the facility. We had Mr. Goki talking about robotics. So I am going to be talking about the chemical aspect of the component, right? So what we are going to be doing today is we are going to be doing chemistry on a computer, a chemistry experiment on a computer. Do you get it? A real, actual chemistry experiment on a computer.
How is that even possible?
How is that even possible? She's asking me. How is that even possible? That's the exact same question I had when our director, Mr. Quinana, told me about this. He was like how is that even possible? Because you know some of the experiments we do in chemistry, you require heat. So how are we going to even do an experiment like that on a computer? How? So if you, like me, are mind blown, but a bit confused, let me indulge you. So this is what we are going to do. The experiment that I'm going to show you is called heating and cooling experiment. So what you can do is, this is how you can access all our experiments. And I must mention that our experiments are syllabus-based experiments. So we have experiments for grade 10, grade 11, and grade 12. So this is how you access our experiments. I must also mention that you can do the experiments anytime, anywhere you are. You don't have to be confined in a lab. So as long as you just have internet, you can do the experiment. Okay. So this is how you can access our experiments. You can quickly go, you can just search for UFH Labs Land. Is that where everyone is? Is that where everyone is? Okay. So you're going to see here different experiments that we have. So I'm going to choose the one that we'll be doing today. The one that we are going to do today is called water heating and cooling curves. So you click on the experiment that you want, right? So we click on the one that we want. Did everyone click on the experiment? Yes. Okay, thanks. After that, you click on access. After you click on access, you click on configuration. Yes, configuration. After you click on configuration, you will see two experiments there, right? Yes. There's one heating on your left and then one cooling on your right. So you can choose depending on whichever experiment you want to start with, right? But for the sake of this demonstration, we are going to start with heating. So we select heating. Did everyone select heating? Yes. Okay. If you selected heating, you're also gonna come across two options if you want to heat at low heat or you want to use maximum heat. So for this demonstration, we are using high heat. You select high heat. Is everyone okay? Yes. All right. After that, we click on Start Observing. Okay, so before we get started, let me just quickly give you a theoretical background of the experiment. So this is a grade 10 experiment, and the knowledge area is matter and materials. Who can tell me what is matter? What is matter? Please define matter for me. Anyone?
Matter is anything that has mass and occupies space.
Okay, that's good. That's a perfect answer. Okay, so matter exists in 3 different states, which is solid, liquid, and gas. What is the shape of a solid?
It has a fixed shape.
It does not change, right? Yes. Okay. And liquid? Takes the shape of its container. And gas? Okay, completely fills out whatever container that it is in. That's good. That is good. Okay, so a matter can change between these 3 phases that we have defined, depending on whether you add heat or you remove heat, right? Okay, so there's 3 changes of state that you should know about, which will be your melting point, your freezing point, and your boiling point. What is a melting point? Who can tell me what is a melting point?
The temperature at which the solid is at equilibrium with its liquid state.
Okay, and the freezing point? Okay. And the boiling point?
The temperature at which liquid changes its state into liquid.
All right.
Yes.
Okay. That's a perfect answer. Okay, so now that we've gotten that out of the way, I think we can start with our experiment. So what is the aim of the experiment? What do we aim to achieve after this experiment? So after this experiment, the learners will learn the characteristics of each state of matter, which is solid, liquid, and gas. They will also be observing the changes that ice or water goes through as it is being heated or as it is being cooled, right? Okay, we can get started now on the experiment. So we are all here on Labs Land University of Fort Hare heating and cooling curve experiment, right? Okay. So we've all clicked on observation, right? Okay, do we all see two camera screens in front of us? We do? Okay. So the first one on your left is the process camera. That one, it captures the changes that ice undergoes as it is being heated. And the one on your right is what? Is the temperature camera. That one, it captures the temperature of the ice as it is being heated, right? Okay, so she asked me, how is it even possible? We don't see any apparatus, we don't see anything. Like, how are we even going to do this experiment? Okay. All right. So this is how we set up for the experiment. We had a hot plate as our source of heat, right? We said you need some sort of heat for the matter to move through different phases, right? So we had a hot plate as our source of heat. We had a known volume of crushed ice, right? So what you see please look on your screens. Please look on your screens, yes. So you see the hot plate, you see the ice with a known volume of ice on a beaker. You see that thing that's inserted on the ice, that is a thermometer. What is a thermometer? Yes, exactly that. Okay. So what we want to see here is, we want to look at, just like any other experiment actually, you need to define what your dependent variable is, what your independent variable is. What is a dependent variable? What is an independent variable? So in our case, our independent variable, let me first start by defining what an independent variable is. An independent variable is the one that we choose to change, right? We choose, it's up to us that this is how we want it, right? So in our case, it is what? It is the time, right? So the time that we choose we all agreeing, right? Yes. This is the time that we all choose. This is the time that we all choose to use. So we're going to use what? 2 minutes intervals, right? Yes. Okay, that will be our independent variable. And then the dependent variable is the one that changes its value depending on the changes that you make to the independent variable. So in this case, it will be what? No, the temperature. Thanks. All right. So now that we've defined that, you have notes there, you have papers there in front of you, because I want us to, whatever you're observing, right? I want you to write it down there. There's a place where you're supposed, it's on page 7. Yes, there's a table there where you're supposed to write what you are observing. What happens we said we're going to use how? 2 minutes intervals, right? Yes. Okay, so you're gonna tell me what you observed when the time was on 0. What was the temperature when the time was 0? And how did the ice look? How did the ice look? Was it solid? Was it liquid? Was it what? That's what you write on the table. That is what I want us to do right now. So if you look closely there, is everyone there? So if you look closely there, you're going to see it's called choose the play rate. Do you see? Do you all see?
Yes.
Okay, so we have different options there, right? We have different options. We have 1, we have 5, we have 10, we have 15, right?
Yes.
You all got it, ne?
Yes.
Puti, are you fine? Yes. Okay, that's fine. So for this demonstration, this simply just says that you can choose how fast you want the video to go or how slow you want the video to go. Totally up to you. Totally up to you. But for the sake of this demonstration, we are going to use what? We're going to use 1, right? Okay. So basically, that is what we do. You're gonna tell me what did you observe when time was 2 minutes. At 2 minutes, what was the temperature at 2 minutes? What was the temperature at 4 minutes? What was the temperature at 6 minutes? What was the temperature at 8 minutes? That's what we want to do, right? Okay. Because these are the values that we need to plot our graph. Everyone gets it, right? Okay. So let me just tell you what you are expecting to get. Let me show you how your graph is going to look like if you are heating up ice at a consistent heat. Okay. So this is how your graph is meant to look like. We said we are plotting what? Temperature versus time. So as you can see, say between, what does that flat line indicate? What do you think the flat line means?
So it's not changing.
Okay. Yes. And what else does it indicate?
Equilibrium.
What? The temperature is constant, right? And what else? What else do you think is going on there? What else do you think is going on? The ice is melting, which means it's changing the phase. It's changing from solid, what it was, to liquid. And then you heat it up again consistently, and then it goes up. And then you get another flat line. So those flat lines, they're just an indication that they indicate the change in phase, different changes that the ice is going through until it reaches the final phase, which will be your what? Your gas. We all get it, ne? Yes. So that is how your graph is meant to look like. Right. Let's go back to Labs Land. Let's go back to Labs Land. Let's go back to Labs Land. You just click back from where we are, click back. Back again. Back again. So we did the first part of our experiment, which was heating ice using maximum heat. Now let's go to the second part of our experiment. Let's go to the second part of our experiment. Okay, seems like something is wrong with my computer, but it's fine. That is fine. Let's see where you are. So you can just say back to, you can go back. We are going back. Is everyone with me? Okay. Right, is it fine? Okay. Thank you, Mr. Boy. Okay, so we are now doing what? The second part of our experiment, which is cooling. Is everyone there? Is everyone there? Are you fine? Are you okay?
Yes.
Okay. So what is cooling? Cooling is just simply what the reverse of what we just did. That's what it is. So let's start. Are we all there? Let's all click on Start Observing. Did we all click on Start Observing? We did. Okay, just like the first part of the experiment, you are going to see screens, your process, one which captures the water, but the difference is now we have what? We have ice in there to cool the water. And then you also have your thermometer to capture the temperature of the water as it is being cooled, right? You guys, you also have your notes there. We can all start observing. Let's use the speed, the first one, 1. Let's use 1. We are on 15 seconds now. I want you to tell me what the temperature is at, say at 2 minutes. Tell me what the temperature is at 2 minutes. Is everyone here? You can see on your right that the temperature is slowly going down. Yes. It is slowly going down. Tell me, what is the temperature of the water after 1 minute? Who can tell me? We are all observing, right? What is the temperature at 1 minute? It was 52, right? Please write it down on your... So essentially, this is what you do in this experiment, depending on the time intervals that you choose to use. You can use one, whichever. You can use 1, you can use 2, you can use 3. It's fine. Everyone fine? Everyone is good? Okay. Everyone is fine. So after 2 minutes, we're on 2 minutes now. What is the temperature after 2 minutes? What is the temperature? 36. Please write it down. Like I said, it's totally up to you how you want the video to go, how fast. If you feel it's too slow for you, you can choose another option. There's different options there. Totally up to you. It's fine. Good. Everyone is recording, right?
Yes.
After 3 minutes, we're on 3 minutes now. And the temperature after 3 minutes? What was the temperature? Okay. So basically that is what you do. That is how you do this experiment. You've all recorded your results. So essentially that is how you do the heating and the cooling experiment. Thank you all so much for coming, and thank you you guys wherever you are watching. Thank you so much for tuning in and watching me perform this experiment. Thank you. Before we go off, I would like one of our audience, one member of the audience do you have something to say? All right, over to you.
Good day, ladies and gentlemen. Standing before you is Drambilia Mona from Zululas High School, and I would like to thank the University of Fort Hare for giving us the opportunity to do experiments online. They were very informative, and we'd really like to appreciate that. Thank you.
Good morning, ladies and gentlemen. Standing before you is Lisomafu. I would like to thank the University of Fort Hare and also FOST and all of its partners for giving us this opportunity. This is also a learning experience for us. We are greatly thankful for that, for this new environment of learning. This has really tested our adaptability. Thank you.